How many guys are farmers and ladies? Okay, we got a few farmers. I want to make sure. You know, close to Washington, D.C., I don't know, you might be government people. I'm talking about fertilizer, I don't know. How many do you use in-furrow treatments of some kind? Any of you guys use black in-furrow treatments? Okay. Just a few? Okay. Anyway, Actagro is a manufacturer of organic acids, and that is a byproduct, or I say a byproduct of lanternite. Lanternite is decomposed plant material that's millions of years old, and we take lanternite from North Dakota, and the reason why we get it from North Dakota is because it has a high extraction rate, about 90%. What we do is take about 2 foot of topsoil off. With a backhoe, we dig the lanternite up, put it in a rail car, and send it either to Arkansas or California, and make a bunch of black products that CPS sells and you use. And I can go any direction you want to go, so just ask questions or whatever. I have a lot of BS in me. Anyway, anybody know what an EDTA is? It's a chelating agent. If you take zinc, which is a metal, EDTA has 6 bonds. 1, 2, 3, 4, 5, 6. You got sequesters, lignin sulfate, citric acid. They're all chelating agents. They have different bonds. The more bonds, it helps you use it in a way that it doesn't mess up your spray or your fertilizer. It's user friendly from an operation standpoint. The challenge is, if this is a soil or a leaf surface, is to get that metal into the leaf or up through the roots. Now we can use sequesters, which are better at that, but we don't use a lot of sequesters in the marketplace. Why? It doesn't have a lot of bonds. Why is that important? The more bonds, the easier it is to mix. You ever have a spray tank go to poop on you? And all won't come out the sprayers and stuff, the nozzles and all that kind of stuff? Well, you maybe use a sequester or lignin sulfate. Now from a plant standpoint, you get better uptake. Let's throw that down. So, where am I going with this? You look at organic acids, which I just told you is lanternite from decomposed plant material. If you look at, anybody know what organic acids are? Anybody heard of humic acid, fulvic acid? Well, they're components of organic acid. So you have humic acid, you have fulvic acid, we'll call that number 1. Number 2, these have a huge net negative charge. Why is that important? Who cares? Nobody? Okay, nobody cares. Well, it's important because you have a huge net negative and you're full of a lot of nutrients that have a positive charge. It's able to hold on to more nutrients. So you put this in a fertilizer mix or from a soil, this in your soil, in this ground. If you look at a soil test, everybody got their soil test with them? He's doing that on purpose. I do the same thing, so that's why I know he's doing it on purpose. If you look at your soil test that they handed out at your front desk, I don't have a copy myself. You look at the base saturation. Go to the base saturation on number 1. You'll see there's base saturation of potash, magnesium, and calcium. It's also sodium and hydrogen. Now equal to 100%. I don't get caught up, sometimes you'll get 101%, but that's the lab just made an error. It's only 100%. If you take, and this is called the soil tilth index, you take calcium and divide that by magnesium, number 1, right? The percentages, you come out with about a 6. From a chemical standpoint, that's telling us that you can take a soil penetrometer, put it in the ground, push it right down the ground without any trouble. You got good soil tilth. What else is that telling you? Excellent ground to put out soybeans, alfalfa. Why is that important? Those crops take a lot of nitrogen. Grow 60 bushel soybean crops, 540 pounds of nitrogen. Where's that come from? It comes from the air we breathe, which is called N2 gas. 78% of the air, tasteless, odorless gas that the nodules on your soybeans convert to usable nitrogen. Be good drainage. The rain comes and pushes the air down. What becomes behind that moisture is air, and it's able to do that. So if you have a poor soil tilth index, you got poor drainage. Maybe that's a field you don't want to put soybeans. How can you impact that? You take fulvic and humic acid, that would actually impact your soil tilth index. It will help with compaction, help with drainage, and improve some of those things. So if you look from a benefit standpoint, you have soil, physical, you have soil chemical, you have microbes, and then the fourth thing is plant stimulation. You look at the four components. You have human. We ground up little kids and we feed it in. No, it's good. And we have carbohydrates. Human, fulvic, and humic acid all come from lanternite. Most products on the market today, this have humic and fulvic. Has that huge net negative. It's able to impact soil physical and soil chemical. Chemical means I got a lot of phosphorus. You look at the soil test. Here you got 100 to 200 parts per million of P. More than enough P to grow a 300-400 bushel corn crop. But is it plant available? These organic acids will help liberate, take some of that P that's in phosphate, zinc, or aluminum, or iron, or calcium, and put it back in the soil solution to help uptake. This human feeds microbes. Why is that important? You're harvesting pretty big yields, right? If it's a 400 bushel yield, you got a lot of fodder. Then it's hard to plant through, and then what's all your nutrients tied up? It's either organic matter or the fodder. So we can break that down faster and liberate it, get more access to our plants that we're growing, the better crops we'll have. And this carbohydrate that we add is sugar. So there's 8 different sugars or acids, and they actually help plant stimulate. And we got a product over here called Black Label Zinc. It's black because lanternite's black. For you, you know it's black. Why do we put zinc in that product? Now it's a phosphorus-based product. Why would we add zinc? Just another gadget in there so we can charge a few more dollars, right? Make some more money. Go and laugh about you farmers. No, we put zinc in there. If you take this soil, which has a lot of phosphorus in it, you pull a petiole sample, right? If you're looking at petiole sample at this stage, you want to pull this leaf. Fill a quart-size bag, roll them up, put them in the bag, send it to agri-analysis, and they'll do analysis on you. And they might come back and say, poor phosphorus. What's going on there? Well, you might be low in zinc. Now, at this stage, you wouldn't make an application of more or less you're out with a fungicide, but the corn was this tall and you did the same thing. Go out there with zinc, and I bet your phosphorus level will come up because zinc is needed for phosphorus assimilation. So that's why we add zinc to Black Label Zinc. The other thing is, from a root standpoint, you look at a product down there called Riser. That's a 7-17-3. Has some micros in it, and it has a zinc ammonium acetate, or also known as ASA. Why is that important? Zinc ammonium acetate is a precursor to auxin. You elevate the auxin in a in-furrow treatment, you'll trick that plant to be photosynthetically active. Before the seed's in the ground, here's my seed. Now put it in the ground, cover it with dirt, and it germinates, gets moisture, and it germinates. It gets that first shoot. Is it photosynthetically active? No, it's not. It has to have its first true leaf. You put zinc ammonium acetate, it thinks it's photosynthetically active because it raises the auxin level in the plant. When it gets photosynthetically active and starts producing chlorophyll, the auxin level comes up and it knows to excrete sugars into the soil to mine nutrients. That zinc ammonium acetate tricks a plant. That's why you can be anywhere from, if you let nature take its course, can be anywhere 7 to 21 days after you put that seed in the ground. To get enough heat units, enough moisture, get that plant to be photosynthetically active. If the heat units are there, you can hasten maturity, make a 100-day or 110-day variety act like a